So you've decided to pick a large language model. You dive in and whoa, Llama, Mistral, Quen, Phi. There are literally hundreds of them, all with different sizes and scores. It's a lot. How in the world are you supposed to choose the right AI for what you actually want to do without getting totally lost in a sea of benchmarks? Well, to figure that out, we first have to understand how we even measure these things in the first place. And hey, if you're feeling that way, you are definitely not alone. This quote from a user on the local llama subreddit just nails it, right? We all see these leaderboards packed with endless scores, but a lot of the time, they don't seem to have anything to do with our real-world experience. It's a super common frustration, and it brings up a really important question. Is that giant model with 400 billion parameters always the right tool for the job? The short answer? Nope, not at all. There's this idea that's becoming more and more relevant called LLM overkill. Basically, it's the idea that using the most powerful model you can find might not just be a waste, it could actually be way less efficient. So if we can't just pick the one at the top of the leaderboard, how do we make a smart choice? Well, we can start by taking a page out of the experts' book, the researchers who actually build and study these models. They don't just look at a single score. They've developed these really systematic ways to bring some order to all this chaos, breaking down a model's performance into clear, measurable parts. Okay, I know what you're thinking. A chart like this looks pretty intimidating at first glance. I totally get it. But honestly, just think of it as a secret decoder ring for understanding any AI model. And the best part is, we can boil this entire complex map down to just 3 core pillars. All right, pillar number 1 is keepability. This is the raw horsepower. What does the model know? How good is it at reasoning through tricky problems, like math or logic? And can it use other tools, like a search engine or a calculator, to help it out? This is all about what the model can actually do. Second, we've got alignment, and this one is a really big deal. It's not just about what the model can do, but how it does it. Is it helpful? Is it honest? Is it harmless? This pillar digs into things like truthfulness, bias, and whether the model spits out toxic or unwanted stuff. It's all about making sure the AI behaves in a way that's actually useful and predictable for us humans. And our third and final pillar is safety. Is the model stable? Is it reliable? What happens when you throw it a curveball, or even when someone tries to deliberately trick it into misbehaving? This is all about making sure the model is tough, trustworthy, and doesn't create some new risk you didn't see coming. Okay, so capability, alignment, and safety. It's a nice, neat framework, but what does it actually look like in the real world? Let's check out this fascinating case study from some Stanford researchers. They put that first pillar, capability, to the ultimate test with one of the most complex, high-stakes tasks you can imagine, U.S. tax law. Now, the setup here was just brilliant. They generated thousands of completely new, multiple-choice tax problems. And because every question was brand new, with random names and numbers, there was just no way the models could have seen the answer somewhere online. This forced the AI to actually reason about the law, not just regurgitate something it had memorized. And the results showed a really clear pattern. The newer AIs were just way better. The oldest model, Da Vinci, could barely get off the ground. But then you get to GPT 3.5 Turbo, and especially GPT-4, and boom, you see this massive jump in their ability to handle these tough legal questions. So yeah, more advanced models really are more capable. But, and this is the most important part, that raw capability isn't the whole story. Not even close. Even the best model they tested, GPT-4, when it was just left on its own, was often less than 60% accurate. For tax law, that's a failing grade. It just goes to show you, even the smartest model is flying blind if it doesn't have the right help. This is where the whole experiment gets really exciting. The researchers started wondering, okay, what if we stop treating the AI like it's taking a closed book exam? What if, instead, we treat it like a real attorney who gets to look up the law and see examples? And the result was just incredible. When they gave GPT-4 the exact legal text it needed for each question, and then showed it a few examples of how to answer, the performance just exploded. I mean, just look at that jump on the chart. It's a completely different ballgame. On the most complex questions, the ones from the Code of Federal Regulations, the accuracy shot up to 92%. It went from a failing student to the top of the class, all because they changed the technique. This proves it's not just about the model you pick, it's about how you use it. Okay, So what does all this mean for you, trying to pick a model when you don't have a team of Stanford researchers to help? Well, this case study shows us that those academic benchmarks for capability are only one small piece of a much bigger puzzle. So let's connect all this back to our original problem, that gap between how researchers see AI and how we actually use it. This slide just gets right to the heart of it. On one side, you've got researchers, and they're focused on these big, abstract ideas like reasoning and truthfulness. But on the other side, you have actual users like us. And as we saw in that Reddit thread, we have very practical concerns. Can I even run this on my hardware? Is it uncensored or heavily filtered? Can I use it for my business? How fast is it? There's a huge gap between the lab and your laptop. So let's put together a practical toolkit, a checklist based on what users really care about. First, define your use case. Are you coding or are you doing creative writing? They need different things. Second, be real about your hardware. VRAM is almost always the biggest bottleneck. Third, check the license. You don't want to build a business on a model that's not for commercial use. And finally, test its behavior. Does it give you the kinds of answers you need or does it refuse? The right answer depends entirely on your project. This practical approach is great for helping us today, but looking ahead, the whole way we think about testing AI is evolving. It's starting to move way beyond just ranking models on a static leaderboard and towards something much more dynamic and purposeful. And all of this leads to a final, bigger question. What if evaluation wasn't just a final exam to see which model is best? Researchers are now exploring what they call enhancement-oriented evaluation, which is a fancy way of saying they're using tests to find a model's specific weaknesses so they can go in and make it better. The goal shifts from just picking a winner to actually building a better, safer, and more aligned AI for everyone. And that is a future that's definitely worth testing for.